All right, so here we go. Formula for arithmetic is right there. So I have n over 2, 200 over 2. Some of you are 200. Guys, what does the formula say? S sub n. What does this say? So what's n? 200, absolutely. So we got 200 over 2 times the first term plus the 200th term. This says a sub 200. Do I know that? No, this is the hard one. Because I can't go on with the problem until I know what that is, right? How am I going to find that? I'm going to use my A formula for arithmetic. So A sub 200 will be the first term plus the difference times 199, which is n minus 1, 200 minus 1. So then I can figure out that number. And that number is 599. Not the answer to the question. That is the number that goes here. So I'll take 599 and add 2. So the answer to this question is 60,100. Okay? Now I know I'm the teacher, so I'm obviously going to be faster than you are at this. But honestly, guys, that should not take 10 minutes. That is not a 10-minute problem for anyone. Now, the other ones are going to be faster. Because that's the only kind of problem that requires that second step. All the rest of them are going to be golden. So here we go. Look at the question. Arithmetic or geometric? You know it's one of these formulas because it says so. Which one is it going to be? Well, I don't know. I have to figure out if it's arithmetic or geometric. So what is it? Geometric. Geometric with a ratio of 4. So I'm using that formula right there. A sub 15 is 3 times 4 to the 14th. And I mean, that's it. There's no second step. There's nothing. It's just that. So this is our answer. Okay? About this. Arithmetic or geometric?
Arithmetic.
Common difference is
6.
6. So I'm going to use my arithmetic A formula, term formula. So A sub 215 is 5 plus 6 times 214. Right? How long does that take to do? If you pay attention, it's so easy. All right, what is that answer? $12.89. All right, we have one more. Geometric?
Some.
Summing, so I'm gonna be using that formula right there. Gotta have my ratio, now what is my ratio? 1/10, multiplying by 1/10. So, here we go. 10 minus 10 times 1/10 to the 8th over 1 minus 1/10. Just plugging in my first term, my ratio, and that's it. I always like to do this first, I keep saying that. What's 1 minus 1/10? 0.9. 9/10. 9/10. Don't forget to hit equals. Hit equals after you type all that in, and then divide it by 0.9. And I got 11.1 repeating as my answer. Okay, that's what your quiz was. This one counts. So I hope you did better than it seems like you were doing. Yeah, we just went through and practiced again, so we're on our way. The ratio is 1. We typed in 0.9. Oh, I probably should have. All right, so let's look at our first practice quiz. Practice test, I mean. Arithmetic or geometric formula. All right, so here we go. Number 1A. Give a common ratio or common difference. All right, so what do you think about A? You should have this done already, those of you that are working on it. A is a neither. You can see the pattern, but why is it a neither? Because we aren't adding the same thing. You can see what we're adding there, but it's not the same thing, so that's a neither. All right, what about B? Arithmetic with a difference of 3. All right, what about C? Geometric with a ratio of, what am I multiplying by? -1. How about D? Arithmetic with a difference of -2. And finally E, geometric with a ratio of 1/4, 4.5, whatever you were doing. Why is it so important that you can figure out if it's arithmetic or geometric? So you know which formula to use, right? So always, that's gonna be the first step. Okay, now we've got this guy. This is what we just had on our quiz. Got some kind of a sequence, and it says find a sub 16. So I will be using this formula or this formula. Those are my only choices because it says so right here. So which one's it gonna be? The bottom one. Isn't this thing arithmetic? What's the common difference? 6. So using that formula right there. So the first term is -2. The difference is 6. And n minus 1 will be 15. So our answer is 88. number 3 is exactly the same thing, kind of thing, only this time it's an S formula, so I'll need my S formulas here. All right. Gonna use one of these. It's geometric with a ratio of 2, and good, because those are the easier ones. If it's geometric with a ratio of 2, so plug everything in. So 3 minus 3 times 2 to the 12th over 1 minus 2. So just plugging my numbers, my first term and my ratio, into my formula. Everybody okay with that? So I'm going to go ahead and make my bottom -1, and then here we go. I got 12285, so 12,285. That okay? Now, number 4 was not on your quiz because it was what we just talked about yesterday. What does this S not have? A subscript, it doesn't have an N. So this told me I'm going to take that sequence and add up the first 12 terms. When there's no N, what does that mean? This is what we did yesterday. It means we're going on infinitely, forever. And that formula, we didn't have any on the quiz, but it's added to your list. That formula is this. Remember that from yesterday? So it's really easy to use. What is, the first term's 30. What's my ratio? What am I doing here?
0.5.
0.5. 1/2, 0.5. So I have 30 over 0.5, 1 minus 1/2. And that is 16. That was not on your quiz, but you will recognize it because there is no number here. So the only option you have is this formula right here. We'll do a little bit more than I want to get your test back to you and share one more piece of information. Let's go ahead and do number 5. These are the limits. This also is not on your quiz, but it will be on your test. We have to be able to figure out our limits. All right, so A, B, C, D, E, and F. Look at all of them. Does anybody have an idea for any of them? We don't have to go in order. If there's one you're sure you know, you can get it first.
Put the first one in -1/2.
Just a second, you said what?
-1/2.
-1/2, she says for the first one. What do you think? Kyle's nodding, that's always a good thing. When we've got n's over n's, don't we box them in? So we have 2n over -4n. Remember, they don't have to be on top of each other. We just have the same n. So we have 2n over -4n. I think she's right, -1/2. Good. Another one, you don't have to go in order, any of them. Levi?
Would B be 5/7?
B would be 5/7, Levi says. What do the rest of us think? For the very same reason, isn't it the same as Gabby's problem? Only they're n squares. Perfect. All right, How about another one in the list?
C is 0.
C is 0, Kyle says. What do the rest of us think? Is he right?
Yeah.
Yes, because why?
Less than 1.
The number getting raised to the power, the number in the little parentheses there, is less than 1. And when that number is less than 1, the limit is 0, period. No matter what else is in the problem, it's 0. Good. All right, D, E, and F. What do you think about any of those?
Is E divergent?
Which one?
E.
E, is E, she says divergent. And another way of saying divergent is to write no limit. It's okay to do that. If you would rather write no limit, you can. Is she right? Is that one divergent?
Yeah.
Yeah. Because you know in problem C, the 3/4 is less than 1. That makes the limit 0. In problem E, it's 4/3. 4/3 is bigger than 1, so that means there is no limit. With that kind of problem, something to the nth power, it's one or the other. It's either 0 or no limit. All right, that leaves D and F.
D 0. F
D is 0, he says. I hope all of you agree with him, because he is right. The highest power in the problem, talking about problem D, is 6n squared on the bottom. How many n squareds do we have on the top? 9. So when you box that in, you get 0 divided by 6, which is 0. Right? Now that leaves F. F is the same issue, only flip. Now we've got 2n squareds over no n squareds. So what happens when you do that? No limit. So you either write divergent or you write no limit, because you can't have a 0 in the bottom. Okay, I'm gonna stop there because I really need to get your last test back to you. Before I do that, I want to share, there is a special sequence that I don't think we've talked about, and I think you may have seen it at some point. Has anybody ever seen this sequence? It is a very special sequence to mathematicians. Has anyone ever seen that before? Or maybe heard of it? It's called the Fibonacci sequence. Leonardo Fibonacci. Anybody see the pattern? It's kind of tricky. We haven't talked about work like this before. Goes up by what? It goes up for sure.
Number behind.
Exactly. So the next term in the sequence would be 55, because I add these two together to get it. See how you add 8 and 13, you get 21? Then you add 13 and 21, you get 34. That's called the Fibonacci sequence. It is all over the place, believe it or not, in nature. Next time you're walking around the woods, find a pine cone, you'll notice, unless